So turns out I'm doing the right thing after all. So in a simple ejection, okay, so here we have a page that's running some kind of server-side engine. You have to be off the City College wireless network in order to connect to it. Yeah, we will. All right, and so if you inject curly braces 2 times 2 with double curly braces and search for that, then you find user 4 exists. Yeah, and there's a question about the scheduling. Let me just address that. There should be, yeah, there's extra room at the end. We'll be okay. And that last topic is optional anyway. There's always some extra room in my classes for this reason, so special events can come up. All right, anyway, so that shows that it's doing processing. That's the equivalent of putting in an apostrophe and seeing a SQL error. You've now shown that data from the end user is misinterpreted as active code at the server in this language called template injection. So that's a start. So now we can fingerprint the server. Somebody made a nice flow chart of injections to use to decide which common framework they're using. So first, so here you do dollars with a single curly brace and see if it evaluates. So let's do that. If I put a single curly brace with a dollars in front of it, and then I put in like 7 plus 7 in here. All right, if I search for that, it does not evaluate that. So that means I take the red line here, then I put in double curly braces with math inside it, and that's the one I've already done. Double curly braces. Whoa, curly braces. There we go. And I think no dollars. Let me go back and check my example. Yep, no dollars, but double curly braces. And that one does evaluate the math inside. So I follow the green line here. And now they say put quote 7, quote for the second parameter, to see if it will expand a string. So I'm going to have 7 times quote 7. And that turns into, whoa, an internal server error. Wow. That's interesting. I wonder if I've failed to double curly brace 7 times quote 7. Well, that's a little disturbing, but anyway. What happens if you use double quotes? Still get internal server error. That's interesting. I may have to restart this server to get the actual thing. I'll restart it or restore it from backup in case it's been trashed. All right. If you want to turn in the 197 forms, just turn them in before finals week. So in the last week of class is fine. All right. All right. So anyway, I did that. And here, that's interesting. Oh, this is the one you need for the flag. Right. Well, I'm going to have to restore this this server from backup then to get it back to work. I've got cloud back. Oh, there it goes. Okay. I must have somehow typed a funny character. So it multiplies 7, the string, 7 times, making a longer string. Okay, that's good. All right. So now we can see how we're going to hack into it, because the way this all works is the data you feed is being sent through Python 3. And Python 3 has some real disturbing security flaws. So if I just take a command line on a Mac, it's got Python installed, so I can just launch it with Python 3, and we can use the interactive mode here. So if I make a string equal to hello, and I spelled it wrong, but it doesn't matter, but I do need to have single quotes at the start and the end. All right, now you can do a string is not just a data string, a data structure in Python. It is an object, and in that lies the weakness we're going to exploit. You can do a directory of the string, and you'll see you can do many things with a string. You can format it, you can encode it, you can decide if it's alphanumeric, you can decide if it's numeric. There are many, many methods you can do with a string. So a string is an active object. You can run code on a string. So if I want to see what that string is, I can do s _ class _ because that was one of these options, class. Okay, so if I do that, it will tell me it's class string, which is not too surprising. It appears to be a string. It's actually a string. Now I can do s.lower is a method. That will be the lowercase, and I can do upper. That'll be the uppercase. All right. And now if I run s lower without the parentheses, it gives me the address of that method. So without the parentheses, it's the name of this method, which has a location in memory where it lives. With the parentheses, it runs that method. All right, so that's a game. All right, now I can see what I'm doing. So now I'm going to walk up the hierarchy. So I do s.class, right, 2 double underscores. That's a string. But if I want the class of this, it's now a type. And it turns out if I want to get all the way up, I do base as the second one. And now I'm up to the object. So I have walked up through the hierarchy of objects. I had a string. By doing underscore, underscore, class, underscore, underscore, I get up to the class of string. By doing base, that should say, by doing class type, I get type, and by doing class base, I get all the way up to object. So even though I was only supposed to be controlling a string, that's why I keep comparing this to SQL injection. In SQL injection, you collect a string from the user, like a username or password, and then by putting in special characters like apostrophes, they can trick the server into treating that as code. And here, by putting in things like this .class .base, I'm able to get all the way up to the root of Python 3, the object base. So now I can make subclasses from there and walk down the hierarchy. Now, that means I'll be able, if I go up here, an object, I'll be able to move down and then find the function called catch warnings, which is some sort of logging function, and then be able to go in there, and that has import. So I'm going to be able, even though I was only supposed to be controlling a string, I'm going to be able to execute a method import and import another library into this app that the developer did not put there. And that's going to give me complete control of the box. So that's the game here. So now we've walked up the hierarchy. Now we're going to walk down the hierarchy. As you can see, we can get there. So if we could get to import, which you see we can do, then we could do this. So we can import OS and import subprocess. All right. And now I can do this. Here's all the available function classes for S-class base, which is the root of object. And there's something like 184 of them. These are all the methods that an object can do. And so we can save that in a variable called C and then count them with length of C. And on this machine, there are 232. And it depends on the version of Python, how many there are. It'll be a variable, like see what I did a while ago, it was 185. Now it's 232, so I apparently have a later version of Python, and there are yet more functions. So I can print some of them. Here I'll print out the first 185 of them. So there's a long list. And so what I want is I want to find the catch warning function. So I'll do this one to print out the ones containing warning. And I'm only trying the first 185 to see if I get lucky, and I didn't. So let's, my machine, I think it was 232. Okay, let's try it with 232. 232. And then this stuff. There it is. Okay, it's 209 on this machine is catch warnings. So now that I've found that number, I can determine that, I can define that as X. 209. All right, and now I can do X module and X module built-ins. Okay, there's the module, and here's the built-in functions of that module, a long blob of them. And so I can store the list of built-ins in a variable called B, find out the length, and then see what I've got here. Whoops, I hit the wrong button. Control C. All right. There. So here I define it in B, the length of B. So there are 158 built-in modules for this object. And if I want to know what it is, I can do the class of it. This is a dictionary with 158 elements. And so now I have to find import, which I can do with a loop, as we've done before. And so there is something called underscore underscore import. and the import will let us import that function. So now we can execute code like date here with X module built-ins, import OS, and now that you've imported OS, you can run os.system and execute the date command. So what we've done, this string and the strings before it that define the variable X and the variable it's based on, now execute the system command date. So that's code execution, all from putting stuff in a string. So here's a test to see if you got that all working in Python. And here's how you do the remote code execution on a web server. So here is where we're going to put in a string called hello, and we're going to call class on it. And remember, we found out that double curly braces perform code execution here, passing it into a Python engine. So that is going to give us type string. So you see I have code execution inside this template injection language, and therefore inside Python I can execute Python code. So now I can do this and go up to the base. All right. That's base string. All right. And now I can do this. This will give the method resolution order is another way to get up to object. Let's try that too. I want to get up to the base, and I got something else. Let's try this one. Class MRO. That gets me up to type object exists. All right, so I've made it back to the top of the tree, so I have an object. I want the third item, so that's going to be MRO number 2. And you put it after the double underscores. All right, hey there. Now I've made it to object, which is where I wanted to get to on the server. All right. And so now that I have object, I can now walk down the hierarchy. So it's going to be subclasses here. Now I'm getting that long list of things, the methods, the subclasses that appear from there. And so here's how I can inject a string using more of this language. Python is going to run a loop and hunt for them, showing the first 10 method types. And then you can run another loop and search until you find it. Let's see if I can find catch warnings. You can put all this multiple stuff in this page. And I found it as 59, okay, which is the same thing it was before. So, all right. And so now I can define a variable X, which is going to be subclasses 59, and then I can run this, which is going to do a system ls. This is going to import the library, OS, and run the system command and do an ls on it. Although maybe I won't do an ls this time. ls kind of has a big long list of stuff, I imagine. I think for this demo, I'm going to take the ls and change it to ID, just to see who I am. And some kind of garbage is blocking it on this machine. But there, my ID is 0, apparently. Let's try date. Let me see if I can get to the right of all this and put in some spaces to make it visible. Oh, let's see if I fouled something up here. OS. System, there's ID. Okay, let me put in some spaces there to get it where I can see it, because the stupid password manager is putting a stupid thing in my way. Let's try, all right, let's try ls, see what ls does. I'm always getting a 0, so something is not quite right here. Let me put this in Opera to get rid of that garbage from the password manager that's getting in my way. All right, and let's try this thing exactly as written. All right, well, I'm not sure what's going on here. Probably, I might have missed a character at the end or something. Let's go back and see. Control E should go to the end. Nope, I got him. All right. Well, I'm not sure what went wrong here. Probably I just have to move more carefully. Oh, no, the result is 0. Okay, sorry, that's the return value of the ls. I see the output of the command did not come back. Okay, fair enough. I'm just freaking out. Here's how you get the output of ls. You have to put it in a file like temp out, and then you have to read it with another command. Okay, fair enough. So I'm just getting expected results and freaking out because I didn't pay enough attention to the instructions. So this will write it into a file and then read the file. Now that should give me an ls. Okay. And there it is, a list of root, so it's the usual root of a Linux system. So that shows you have some control over things. All right, and so now you can exploit this and find flags up there by executing commands as you've done before. So that's what I wanted to show you. Let me stop this.